Welcome back SM online class. In this class, we are going to discuss exercise 5 of mathematical induction. There is question number 1, 1 plus 2 plus up to n equal to n into n plus 1 upon 2. And I go to number ta solve kariche, okay? And number 2, that is 1 square plus 2 square up to n square equal to n into n plus 1 into 2n plus 1 upon 6. एटा भी हमें सॉल्व करिछे सो क्वेश्चन नंबर 3 this is 1 plus r square up to r to the power n equal to what? This is r to the power, this is n plus 1 minus 1 upon r minus 1. Okay, so first 1 is add here, then r square up to what? R to the power n. So here first the statement is given that it is Pn, this is 1 plus r square, okay, plus r to the power n equal to, this is r to the power n plus 1 minus 1 upon r minus 1. Okay, now for n equal to 1, so this is 1 plus, this is r LHS. First 1 is add here, okay, then for n equal to 2 what? This is 1 plus r square, okay, like this. Now RHS, this is r to the power 1 plus 1, this is 2 minus 1 upon r minus 1, and this is r plus 1 into r minus 1 upon r minus 1, and r minus 1 cancel and we get r plus 1. So LHS equal to RHS. So P1 is 2. Okay, now assume it is true for what? N equal to m. Assume it is true for n equal to m. So this is 1 plus r square plus r to the power m equal to r to the power m plus 1 minus 1 by r minus 1. Okay, now we have to prove it is true for n equal to m plus 1. Okay, it is true for n equal to m plus 1. So for this we have to prove what? This is 1 plus r square plus r to the power m plus r to the power m plus 1. Okay, equal to what? This is r to the power m plus 2 minus 1 upon r minus 1. We have to prove this one. So taking LHS, now LHS, this is 1 plus r square plus r to the power m plus r to the power m plus 1. Okay, and for this value equal to what? This is r to the power m plus 1 minus 1 upon r minus 1, and this is r to the power m plus 1. And taking LCM, we get here r to the power m plus 1 minus 1 plus r minus 1 into r to the power m plus 1 upon r minus 1, and it is equal to r to the power m plus 1 minus 1, and this is r into r to the power m plus 1. This is r to the power m plus 2, and this is 1 into r to the power m plus 1, the minus, so this is minus r to the power m plus 1 upon r minus 1. This minus r to the power m plus 1 and plus r to the power m plus 1 cancel, so finally we get r to the power m plus 2 minus 1 upon r minus 1, which is RHS. Okay, so I am LHS nele and we have to prove RHS. So the given statement is true for what? N equal to m plus 1, for which it is true for n equal to m. Hence by principle of mathematical induction this is true. Okay, now move to question number 4. Question number 4, this is 5 to the power n minus 1 is divisible by 4. Okay, for first let the given statement is denoted by what? This is P of n. Factor n minus 1 is divisible by 4. Okay, now for n equal to 1, it is 5 to the power 1 minus 1, that is 4, is divisible by 4, is divisible by 4. So P1 is true. So P1 is true. Then assume that it is true for, assume it is true, it is true for n equal to m plus 1. Okay, now sorry, it is true for n equal to m, so it is 5 to the m minus 1 is divisible by 4. Example divisible लिखिबो. Okay, हम short लिखि देछि 5 to the m minus 1 is divisible by 4, that is 5 to the power m minus 1 equal to हम लिखि परबा कोन 4k, where k belongs to any natural number. Now 5 to the m रो value कोन हबो? This is 4k plus 1. Okay, now we have to prove it is true for n equal to m plus 1. Okay, and for this we have proved, for this 5 to the power m plus 1 minus 1 is divisible by 4. Okay, now 5 to the power m plus 1 minus 1, and this is equal to what? This is 5 to the power m into 5 minus 1, and the value of 5 here m equal to what? 4k plus 1. So 5 into 4k plus 1 minus 1, and this is equal to what? 4k, this is 20k plus 4, and after taking 4 as a common, this is 5k plus 1. So 4 is a common factor, so we have said that it is divisible by 4. Okay, is divisible by 4. Okay, since the statement is true for n equal to m plus 1, for which it is true for n equal to m, then hence the therefore the given statement is true, that is 5 to the n minus 1 is divisible by 4. Now move to question number 5. Question number 5. It is 7 to the power 2n plus, so direct p of n लिखिए. Okay, 7 to the power 2n plus 2 to the power 3n minus 3 into 3 to the power n minus 1 is divisible by 25. Okay, for n is greater than equal to 1. Okay, now for n equal to 1, it is 7 power 2 plus 2 to the power 0 into 3 to the power 0. This is 50. Okay, and this is divisible by 25. So P1 is true. So P1 is true. Assume it is true for n equal to m. Okay, so 7 to the power 2m plus 2 to the power 3m minus 3 into 3 to the power m minus 1 is divisible by 25. Okay, so if this is divisible by 25, so we have right here implies that 7 to the power 2m plus 2 to the power 3m minus 3 into 3 to the power m minus 1 equal to 25k. Okay, or implies that we have 2 to the power 3m minus 3 into 3 to the power m minus 1 equal to what? This is 25k minus 7 to the power 2m. Okay, now we have to prove the statement is true for n equal to m plus 1. We have to prove it is true for n equal to m plus 1. Okay, and for this we have to prove what? This is 7 to the power, this is 2 into m plus 1, okay, plus 2 to the power 3 into m plus 1 minus 3 into 3 to the power m plus 1 minus 1, okay, is divisible by 25. Now this is 7 to the power 2m plus 2 plus 2 to the power, this is 3m plus 3 minus 3 into 3 to the power m plus 1 minus 1. We have to, in this form, this is 2 to the power 3m minus 3 and 3 to the power m minus 1. So it is equal to what? This is 7 to the power 2m into this is 7 square and this is 2 to the power, this is 3m minus 3 into 2 to the power cube into 3 to the power m minus 1 into 3 to the power 1. Okay, and this is 2 to the 4, 4 to the 8, 8 into 3, that is 24. Okay, so it is equal to 7 to the power 2m into 7 square plus, and this is 24 into, this is 2 to the power 3m minus 3 into 3 to the power m minus 1 equal to what? This is 25k minus 7 to the power 2m. Now it is equal to what? 7 to the power 2m into 7 square plus 24 into 25k minus 24 into 7 to the power 2m. Okay, and 7 to the power 2m, 7 to the power 2m is common, so taking 7 to the power 2m equal to common, and it is 7 to the 49, and this is minus 24, and this is plus 24 into 25k. Okay, and this is equal to what? And for 5, that is 25, and it is equal to 7 to the power 2m into 25 plus 24 into 25k. Okay, and after taking common as 25, we get 7 to the power 2m plus 24k, and it is divisible by what? 25. Right here it is divisible by 25. Okay, so next write the conclusion, that is what? Since it is true for n equal to m plus 1, for which it is true for n equal to m, so So therefore the given statement is true for which is 7 to the power 2n plus 2 to the power 3n minus 3 into 3 to the power n minus 1 is divisible by 25 by principle of mathematical induction. Okay, so in this class we discuss exercise 5 question number 1 to question number 5. Okay, 1 और 2 आगुरु आमे करथिले, so 3 4 5 आमे डिस्कस करले, and in the next class we discuss question number 6 onwards. Okay, so till that take care and thanks to all of you.